Okay, so again, my apologies for the video punking out there. Alright, so now we're on part 2. Lots of 2's here. Section 2.2, video number 2, part 2. Rates of change. So we left off. The average velocity of a function is found by determining the change in position with respect to time. The instantaneous velocity, and I kept that in parentheses because you won't see that normally. You would just be asked for the velocity. The velocity function is the first derivative of the position function. And I will refer to this often. The average velocity is the slope. The instantaneous velocity is the derivative. So this would be slope of a secant line, because you're always given an interval to find an average rate of change. And then derivative, we know, derivative of the tangent line. So instantaneous velocity, we're determining the velocity at an exact moment. Alright, so let's finish with our example. We had this position function, negative 16t squared plus 100. I asked you for the average velocity. We found that to be negative 48 feet per second. And now what I want you to find is the velocity of the object at exactly 1 second. So notice instantaneous velocity is not written. So if I'm looking for the velocity is the first derivative of the position function. So the first derivative using the power rule would be negative 32t. So the velocity at 1 second would be negative 32. Now if our secant line is feet per second, the velocity would have the exact same units because it's still a rate of change of position with respect to time. If I ask you for the velocity at 2 seconds, negative 64 feet per second. Okay, so the last examples we're going to look at, they're from page 117 in the textbook, numbers 93 through 96, all of the same directions. So you don't need to write these down if you just label this for yourselves. Okay, so we're doing a couple things here. Find the average rate of change of the function over the given interval. Compare this average rate of change with the instantaneous rates of change at the endpoints of the interval. Okay, so what I left off saying, average rate of change, that's your slope of the secant line. Instantaneous rate of change, that would be your derivative. Okay, so number 93, the function given is f of t equals 4t plus 5 on the interval from 1 to 2. So first find the average rate of change. So find the slope of the line, connecting the two endpoints, f of 2 minus f of 1 all over 2 minus 1. 8 and 5 gives me 13, 4 and 5 gives me 9 all over 1. So my average rate of change would be 4. Now the instantaneous rate of change comes from the value of the derivative. So f prime of t is 4. So the instantaneous rate of change everywhere is equal to 4. So in this case, the average rate of change and the instantaneous rates of change are equivalent. That won't always happen. Okay, number 94, our function is t squared minus 7 on the interval from 3 to 3.1. So first the average rate of change. That's just the slope connecting the endpoints. F of 3.1 minus f of 3 all over 3.1 minus 3. Alright, so we have 3.1 squared, 1, 3, and then 3, 9, so 9.61. I have to subtract 7 from that. So 2.61 minus f of 3, 3 squared is 9, minus 7 gives us 2, all over 0.1. So we have 0.61 divided by 1/10. So the average rate of change would be 6.1. Compare this with the instantaneous rate of change. That's the value of the derivative at each of the endpoints. F prime of 3 is 6. F prime of 3.1 is 6.2. So in this case, our average rate of change is right in between the instantaneous rates of change at the endpoints. So just to familiarize yourselves with this notation, average is the slope of the secant line connecting the endpoints. Instantaneous rate of change is the value of the derivative at a specific point. 95, the function is negative 1 over x on the interval from 1 to 2. So the average rate of change, f of 2 minus f of 1, all over 2 minus 1. When I plug 2 into my function, negative 1/2 minus a negative 1, all divided by 1. So negative half plus 1, my average rate of change is a half. In order to find the derivative, we first have to rewrite the function in the form x raised to some power. The derivative, negative 1 times negative 1 gives us a positive 1 to the negative second power. So 1 over x squared. Now the value of the derivative at each endpoint. The derivative at 1 is 1, and the derivative at 2 is 1/4. So in this case, the average rate of change is a little bit bigger than the instantaneous rates of change at the endpoints. Alright, and the last example, 96, is a trig function, f of x equals sine of x on the interval from 0 to pi over 6. So the average rate of change, f of pi over 6 minus f of 0. Alright. Pi over 6, the sine function is a half. So 1/2 minus 0 all over pi over 6. So that's 1/2 times 6 over pi. So 3 over pi would be our average rate of change. Now the instantaneous rate of change, first find the derivative. Derivative of the sine function is cosine of x. So f prime of 0, cosine of 0 is 1. F prime of pi over 6. Cosine of pi over 6 is square root of 3 over 2. So comparing these values, this would be 3 divided by 3.14. So this would be a little bit less than 1. 3 divided by pi. So again, it'll be a little bit smaller than the instantaneous rates of change at the endpoints. Okay, so your homework for Monday, jot these down, and then another video will be posted, and this is the product and quotient rule. Have a good weekend.